Welcome to this episode of AI Frontiers, exploring visionary AI breakthroughs. This synthesis covers 43 papers in computer vision, all dated July 27, 2025, highlighting machines that see, understand, and transform the world through cutting-edge research. This presentation provides an overview of the visual revolution in AI. A dive is taken into 43 papers from July 27, 2025, exploring AI's visual prowess. Foundations, themes, findings, methods, spotlight papers, and future paths are covered. An engaging narrative is presented, from real-world applications like self-driving cars to ethical AI. A provocative hook is posed. Can machines outpace human vision in creativity and reliability? This guided tour is designed to spark ideas for researchers and enthusiasts alike. Computer vision, often abbreviated as CV, stands as a cornerstone subfield of artificial intelligence. Machines are empowered to interpret and understand visual information from the world, including images, videos, and 3D data. At its core, processing occurs on pixels to extract meaning, such as recognizing faces in a crowd or detecting tumors in medical scans. Impacts are seen in healthcare for faster diagnostics, security for smarter surveillance, and entertainment for immersive experiences. Challenges like noisy data in low light conditions or biases in diverse datasets are addressed in these papers. The human element is evident, with researchers driven by motivations such as building real-time sign language tools for underserved communities like India's deaf population. A key research theme emerges in multimodal integration, where data from sources like images, text, audio, EEG signals, or infrared are fused to enhance performance. This approach boosts robustness, particularly in challenging environments such as nighttime driving. For instance, visible and infrared images are combined adaptively for object detection in misaligned scenarios. Another example integrates brain signals with visuals for motor imagery classification, enabling control of prosthetic arms through thought. Transformers are utilized to capture long-range dependencies across modalities, connecting visual cues with EEG data, which is vital for real-world applications like object detection in fog. Another prominent theme focuses on bias mitigation and fairness, addressing how AI can perpetuate inequalities through skewed data. Techniques such as controllable feature whitening are employed to eliminate spurious correlations in image classification. Noisy web data is filtered for vision language models to ensure ethical training. Efforts are made to reduce biases in datasets for tasks like facial beauty prediction, promoting inclusivity across diverse populations. Evidence from the papers demonstrates improved equity without sacrificing performance, making computer vision fairer and more ethical. Efficiency and real-time processing form a crucial theme, essential for practical applications. Lightweight transformers are developed for satellite image classification with minimal labels. Fast densification strategies in 3D Gaussian splatting speed up scene reconstruction by over twice, ideal for virtual reality or autonomous vehicles. Generative and diffusion-based approaches are booming for creative tasks. Diffusion transformers are applied in animating co-speech gestures or colorizing anime sketches with temporal consistency. The technical concept involves diffusion models that add noise and reverse it to create realistic outputs, akin to gradually refining a sketch into art. These methods overlap with efficiency, enabling quick deployment in resource-limited settings. The theme of efficiency and generative approaches extends to adaptation in challenging or niche environments. Low-light enhancement is achieved via multimodal transformers. Unsupervised auto-labeling handles 3D point clouds in messy driving scenes. Fake news detection is performed in emergency videos. Hybrid methods insert 3D objects into videos photorealistically. AI is adapted to unstructured data, such as footprints in wildlife tracking or occlusions in ultrasound imaging. These interconnected themes reflect computer vision's maturation toward real-world applicability, supported by evidence from multiple papers highlighting innovations driven by challenges with limited datasets. Key findings from the papers reveal transformative insights. A model for real-time Indian Sign Language detection achieves 99.95% accuracy using CNNs and hand tracking. A multimodal transformer for low-light image enhancement outperforms benchmarks by fusing 9 data types. Bias reduction through a simple whitening technique attains state-of-the-art fairness in image models on corrupted datasets. Unsupervised auto-labeling for 3D point clouds in autonomous driving reaches over 50% precision without human input. A foundation model for EEG-based motor imagery adapts to new tasks with fewer than 30 trials, outperforming on multiple datasets as noted in Tapia et al. Common methodologies across the papers balance power and practicality. Transformer-based architectures, such as vision transformers or cross-modal variants, handle sequences of image patches or multimodal data, capturing long-range dependencies effectively, as seen in low-light enhancement. Diffusion models add and reverse noise for generative tasks like super resolution or gesture generation, offering vivid results but requiring optimization for computational intensity. Contrastive learning aligns representations by comparing pairs, boosting self-supervised tasks like satellite classification with few labels. Self-supervised and test-time adaptation fine-tune models on the fly for domain shifts, as in fake news detection. Hybrid pipelines blend 3D rendering with 2D refinement for tasks like object insertion, providing geometric accuracy and photorealism. The first selected research paper is by Tapia et al. 2025, titled "Can Foundation Models Predict Fitness for Duty?" This paper is chosen for its innovation in biometrics and addressing data scarcity with foundation models. Self-supervised pre-training is used to assess alertness from near-infrared iris images, detecting impairments like fatigue or intoxication. High accuracy is achieved with minimal labeled data, impacting safety applications in roles like piloting or driving. Transfer learning's power is represented in niche computer vision tasks. Novelty lies in expanding foundation models to health monitoring ethically. The second selected research paper is by Goswami et al. 2025, titled LMCAT, Unpaired Multimodal Transformer with Contrast of Attention for Label-Efficient Satellite Image Classification. This work is selected for its efficiency in remote sensing and self-supervised multimodal alignment. A lightweight transformer fuses unpaired data like optical and radar, achieving 95.4% accuracy with just 20 labels per class. Parameters are reduced by 47 times compared to baselines, making it ideal for edge devices in environmental monitoring. Practical, label-efficient approaches in computer vision are exemplified. The impact revolutionizes disaster response and climate tracking. The third selected research paper is by Zhang et al. 2025, titled Anime Color, Reference-Based Animation Colorization with Diffusion Transformers. This paper is picked for its generative creativity and temporal consistency in video tasks. Diffusion transformers colorize black and white anime sketches using a reference image, reducing color drift by 20%. Professional quality outputs are produced, speeding animation workflows. Diffusion models. Versatility in entertainment computer vision is represented. Novelty involves blending high-level semantics with low-level details for smooth results. Future directions in computer vision point toward explosive growth. Unsupervised methods are expected to advance, tackling data scarcity and ethical issues. Integration with edge computing is anticipated for faster, sustainable real-time applications. Hybrid models fusing vision with neuroscience or language are likely to emerge, addressing unstructured environments. Focus will be placed on standardized benchmarks and bias mitigation for fair AI. Collaborations are encouraged to handle privacy concerns and other challenges. This synthesis was created using AI tools, including GPT-Grok with model Grok 40709. TTS synthesis was performed using OpenAI and image generation using Google. The synthesized content underwent review by a human expert, though some oversights may still exist. All references are provided for further verification and deeper exploration. Subscribe to the AI Frontiers YouTube channel for the latest AI research breakdowns. The channel title is AI Frontiers. Stay updated on breakthroughs and engaging narratives in artificial intelligence. Hit subscribe now and turn on notifications for new episodes. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.